Kalimera, thank you very much for inviting me to this beautiful venue, although unfortunately I can't see anything out there. I'm going to talk about prevention of smoking in adolescents. In fact, you just rehearsed all my arguments, but I'm going to put a few more data points to this. In terms of declaration of interest, you may have seen me just doing this. I am a vapor, but I have not received any funding from the tobacco or e-cigarette industry. Now, when it comes to working out whether or not e-cigarettes, in fact, cause kids to start smoking, which is your question, the best way to assess causality, we know, if you're an epidemiologist, is to use a randomized controlled trial. Now, the problem in this particular instance is that this would both be impractical, but also be unethical. We can't select, say, half of the kids in Attica and provide them with e-cigarettes, and the other half don't get an e-cigarettes and follow them up to see whether they start smoking. No ethical committee, certainly in most countries, would allow this to go ahead, this kind of trial. So direct observation is not really possible to answer the question that you've been posing, whether e-cigarettes cause kids to start smoking. This is not the only discipline which this is a problem. If you're particle physicists, you can't really directly observe an electron either. So you have to try to infer the association using different methodological approaches. And what I will do is I will look primarily at UK and US data. There's a few data points from Greece I could find as well, but unfortunately not very many, to determine whether we should be concerned about this so-called gateway hypothesis. First, I'm going to look at individual level gateways, so using both synthetic and real-world controls. Synthetic being basically case control approach using propensity score matching. I explain how that works. The first study I'm going to represent is a case control design retrospective using NYTS data. Konstantinos just mentioned that already, it was National Youth Tobacco Survey data. And the second is a prospective case control design using PATH data. They're both US data sets. And then I'm going to look at the population level gateway using descriptive and differential statistics as well as forecasting. First of all, very simply looking at trends in e-cigarette use among adolescents in the UK and the US. Before presenting a time series analysis of UK data using the smoking toolkit study, which was run from my department. And then also I'll try to explain, hopefully I'm successful in this, a microsimulation and agent-based model essentially, which is simulating what we would expect smoking prevalence to be like if certain assumptions are met about the impact of e-cigarettes on subsequent smoking. Okay, so the National Youth Tobacco Survey is a cross-sectional survey carried out every year. And I used about 80,000 kids here from 2014 to 17 to select cases and controls. And in 2 years only, 2014 and 15, adolescents were asked which of various products they had used first. And so we can then select cases. Cases being those kids who said the very first product they used is an e-cigarette. It was about 3.2%. And then we also selected a real-world control group. Those kids who use the products very similar to an e-cigarette, but not an e-cigarette. So non-combustible, non-cigarette tobacco. For instance, chewing tobacco, snus, or dip, that's about 1.4%. The reason why we use this behavioral control group is that they're probably quite similar to kids who use an e-cigarette because of various things, including common liability. And so this reduces confounding when answering the question about the impact of use of these products on subsequent smoking. And then we selected a synthetic control, and this is called propensity score matching, where basically you select the kids, your cases, those who use e-cigarettes first. We know what they look like in terms of the sociodemographics, their school characteristics, future smoking susceptibility, environmental tobacco exposure, perceived health effects. And then we select from kids who haven't used an e-cigarette first, those kids that look exactly the same as those who've used an e-cigarette first, based on all these characteristics. So it's a synthetic control group that is selected from the whole sample. And what this looks like, is rather small, is you can see here is in the full circles in the middle that the kids that you select look very similar to the cases that you've selected, so e-cigarette users. So the open circles show you what the sample looks like when they're not matched, and when they're matched, they look very similar, so therefore in the middle line. Or you can see here top the matched treatment units to the matched control units, and they look very similar in their distribution of these propensity scores. Or lastly, the very top you have unmatched controls, and then you look at the differences after you match them, and all the differences more or less disappear. They look very, very similar, right? Now you have a synthetic control group. And the main outcome I'm going to present is ever and current cigarette smoking. So here on the left-hand side, you see ever smoking prevalence, and the right-hand side, you see current smoking prevalence. And first, those kids who use an e-cigarette first. What do we see? If kids say, I've used an e-cigarette first, about 26% go on to ever try a cigarette. And that's very similar to what you see in population surveys when you follow people up. Now, the matched control groups, so those kids that look very similar, but they haven't used an e-cigarette first, in fact, they're slightly more likely to have ever tried a cigarette. And then if we look at our behavioral control group, those who use non-combustible, non-cigarette tobacco, they're even higher. So it suggests that if you use an e-cigarette or not, in this particular analysis suggests that there's no particular increase in ever smoking. Now, if we look at current smoking prevalence, only about 2% of kids who've used an e-cigarette first become current cigarette smokers. And then if you look at those who were matched, the matched control group, in fact, they're more likely. So there's a significant difference there. And then those who use the behavioral control group also are much more likely to be a current cigarette smoker. So this is a significant difference here, suggesting, in fact, that e-cigarettes may be protective when it comes to subsequent smoking. To put this differently, the conversion rate is 3.3%. So if you use an e-cigarette first and then you try a cigarette, only 3.3% of those kids who have used a cigarette after they've started using e-cigarette actually go on to become a current cigarette smoker, meaning it may help some kids to be diverted away from cigarette smoking. And the conversion rate is much higher for those in the matched control group or in the behavioral control group, so 8.8%, 17.4%. Now, we wanted to replicate this analysis, so we looked at path data. The path study is slightly different. It's not cross-sectional, it's longitudinal. And these are data from 2013 to 2016 to select cases and controls. And here we have the advantage of having 3 waves, so we can differentiate our covariates from our exposure from our outcome. And the cases here are kids who at wave 1 said, I've never used any product at all. At wave 2 they said, I've used an e-cigarette, but no cigarette. And that's about 5%. Then the real-world control as before, where this behavioral controls non-combustible, non-cigarette tobacco users at wave 2, no tobacco use at wave 1, or cigarette use at wave 2. And then again, we used propensity score matching to select our synthetic control group. And there are many more characteristics available in paths, and many more variables were included in the selection of these controls for the cases who were e-cigarette users at wave 2. And the main outcome is, again, ever and current cigarette smoking at wave 3. So not at wave 2, but at wave 3. Just to show you that the matching is not quite as successful here because the sample is smaller and because there are more variables being used to match these groups, but still it seems to be sort of sufficient. Now, this is the data from the retrospective analysis I showed you before, and this is the data from the prospective analysis. It is reversed, surprisingly. And so what we see here is, in fact, if you're an e-cigarette user first, then you're more likely to ever have smoked a cigarette in this analysis, whereas there's no difference with the behavioral control group. Now, the conversion rate is also a bit higher at 7.5%, much lower for the matched control group. But for those in the behavioral control group, in fact, the conversion rate remains very high. It's like 1 in 5. Now, why might this be the case? The other thing you may have noticed is that, in fact, smoking prevalence is much, much lower than in the NYTS data. And the reason for this is that the analysis census for adolescents who were most likely to smoke, about 13.4%, because at wave 1, we removed all the kids who have used tobacco already. We only included kids here who were tobacco naive at wave 1 in this analysis. And what this really means is, if you want to know whether or not e-cigarettes cause subsequent smoking, it depends on your sample selection. E-cigarettes can either be protective or harmful, and it shouldn't be really surprising, because the gateway concept is rather problematic insofar as we are interested in a counterfactual scenario, right? So if you wanted to work it out, we have those kids who would have never smoked and those kids who would have smoked, and then they're exposed to some form of e-cigarette, and then there are 2 end states, non-smoker or smoker. Now, we're not really interested in those kids who would never have smoked, who use an e-cigarette and never smoke. Neither are we interested in those kids who would have smoked, who use an e-cigarette and then go on to become a smoker. What we're really interested in the gateway is a crossover. So those kids who would have never smoked try an e-cigarette and become a smoker. And the path data, because we basically select out those kids who are quite likely to have smoked, probably samples this pathway, the A pathway. So we find there's a negative association. So if you use an e-cigarette, you're more likely to become a smoker. The NYTS data, because of the selection of variables at the same time point, the covariates are somewhat confounded with the outcome variable, means you probably oversample those kids who would have smoked in the first place. And so you select this pathway, B, which shows you that there's a positive effect. E-cigarettes divert away from being a smoker. But really what we're interested in is the joint pathway, the aggregate effect. Right? And so at the individual level, it's probably not very helpful to look at these kind of analyses. What really we need to look at is population level effect, so population gateway, as I would call it, to gauge the net outcome of these 2 pathways. Now, the first thing we can do is, in order to look at the population effect, is to just look at the data that are available. So these are data from the US and from the UK. The UK is in a broken line and the US in solid line. This is cigarette use in the past 30 days. Over 2 decades or so, we can see there's a nice decline in both the UK and the US over this time period. Now, this is e-cigarette use over the same time period. And the first thing you notice is that during the time period when e-cigarettes became most prevalent, there was the biggest spike. There was a continued decrease in smoking prevalence in the US and in the UK, suggesting if there's a gateway effect, it can't be immediate. It would have to be delayed. One interesting thing to point out is that if you look at the data, 2013 smoking e-cigarette prevalence among youth in the UK and in the US was similar. By 2018, it had diverged immensely. Right, you can see that the increase is about 4-fold now. But what hasn't changed is the difference in smoking prevalence, which also would suggest if there's an effect, a gateway effect, it would have to be quite small, because you would expect to pick this up if you just look at data like this. So if you look at the period prior to e-cigarettes becoming popular around 2013, there was a steady decline in both the UK and the US, and since then, the decline may have slowed a bit, so you may say maybe there's an impact. However, it should be important to remember that there may also be other causes for this slowing and decline, and colleagues in the UK published a paper this year to suggest, for instance, that also there's been a slowing in the decline in the use of marijuana in the UK, as well as in alcohol consumption. So we can't really make any causal inferences from just looking at these data. I did find a few data from Greece as well here, which I wanted to present, which is these here. So this is smoking prevalence among 16 to 18-year-olds or high school students in Greece. So cigarette use in the last 30 days. It's in the solid line, and you can see there hasn't been much of a decrease of late, but there hasn't been much before either. So this is the period before e-cigarettes became popular. The only data point I could find was in 2014, suggesting that somebody asked this question earlier, that I think prevalence was at around 1%, very low, of e-cigarette use among adolescents in Greece. So this was the decline before, and this is the decline after e-cigarettes have become popular, and there's not really much of a change. So again, I would suggest there's not strong evidence for any kind of gateway effect. Now, as I said, we can't really infer causal associations from just looking at these data, and so I'm going to present some data from a time series analysis that we conducted, which was published in the BMJ. No, which hasn't been published yet, hasn't even been submitted yet. Sorry, this is new data. I'm so sorry. Using a time series analysis of UK data to look at the causal association. Now, just to explain what a time series is, you have a hypothetical time series like this, and what you want to do is you try to remove all the kind of confusing factors that may cause interference. So the first thing you remove in a time series is seasonal effects. It's very common, for instance, in smoking prevalence for this to vary by season. More people stop smoking in January, this is a New Year's resolution, and more people start smoking across the summer months when the weather is nice. Maybe that just explains the high smoking prevalence in this country, given the weather is very nice compared with the UK most of the time. Then you have to remove random effects, which are always present because of variations in methodology, surveys, etc. And then long-term trends. And long-term trends when it comes to smoking tends to be one that is decreasing over time. What you then have is a differentiated hypothetical, differentiated time series, and you can look at the association with another differentiated time series to see whether there's any concurrent or longitudinal associations. And so here I present data from a method that's called Arimax to have a look at the association between e-cigarette use in the UK in 16 to 21-year-olds and smoking prevalence to see if there's an association across time. These data come from the Smoking Toolkit study. About a decade, we look at data across a decade, about 22,000 participants. And the explanatory variable here is the prevalence of e-cigarette use among all adolescents. And the outcome variable is the prevalence of cigarette smoking among all adolescents. And we also included very covariates that we know influence smoking rates. And these are the data of this time period. There's an increase in e-cigarette use in orange here across time and a decrease in cigarette smoking among adolescents, which is good news. And here's the association that we found in the time series. So this is provides a bit more strong causal evidence. And what you can see is there's no evidence of an association at all. The effect is virtually indistinguishable from there not being an effect. However, there have, of course, been studies, certainly in the US, that suggest that the association of e-cigarette use with subsequent smoking is in the order of an odds ratio of 3.5. And we can use Bayesian analysis to work out whether this kind of effect is realistic given the data that we have found. And what we find is that effect is highly unlikely to be correct. In fact, if we look at our data and this proposed effect, we would have to reject the alternative hypothesis and accept the null hypothesis that there is no effect of that size. What we cannot rule out on the basis of our data is whether there's a smaller effect. We have to be agnostic about it. So there could be an effect that means that there's a reduction in smoking prevalence following increase in e-cigarette use of 0.6, the odds ratio being 0.6, or a slight increase of 1.55. But certainly not of the size that is postulated in the US. Now, lastly, I quickly want to talk about a microsimulation. So here we basically create an artificial city. So you just have these agents that run around. They can simulate macro events. It's a bottom-up analysis. And they have their own individual characteristics. And they have certain sets of rules that govern behavior probabilistically. Most famously, agent-based models are derived, for instance, from explaining how neighborhood segregation occurs in the US. And so you give it a very simple rule. You say you have a preference if you're white for white people and if you're not white for non-white people. And then you run the model, and then over time you get quite complex patterns emerging from very, very simple probabilistic associations. And in this particular analysis, I used data from prior to e-cigarettes being popular in the US and the UK to calibrate future behavior in this artificial set of adolescents. So we used here 50,000 agents, 50,000 adolescents. We separated out those below 16 years of age and those above 16 years of age. And in each tick, so at each month, they age a bit, and their smoking or e-cigarette use status changes depending on the rules that we apply. And they're randomly assigned a smoking status initially based on best fit function. And when you look at the data prior to e-cigarettes become popular, in the UK, there was a linear function, which means there's a slow decline over time in smoking prevalence. And in the US, there's an exponential function that best fits the data prior to e-cigarettes becoming popular, which means a slow decline that accelerates over time. And for e-cigarette initiation, this model says just a steepish increase and then levels out over time. This model is quite simplistic, as it only models the impact of e-cigarette use on smoking uptake, not on cessation. So cessation is completely taken out here. And we assume, based on data, that if you're an e-cigarette user, you're 9 times more likely to, if you're a smoker, so you're 9 times more likely to start e-cigarette use than a non-smoker. And there's no prior use of e-cigarettes prior to 2012 and 2011 in the UK and US, respectively. This is what it looks like. Just to show you, it models it. Here are the data from the UK. From 2012 to 2017, these are the postulated data based on past trends, and these are the actual data over this time period. And here's the data if we assume that e-cigarettes increase the likelihood of subsequent smoking by 3.5 times, so odds ratio of 3.5. Very difficult to see any kind of difference from the actual results. And if we assume even a 10-fold increase, you can't see any difference. And if you say there's a protective effect, so it reduces the likelihood, can't see any difference, basically. So for those below 6 years, we can't see any effect of e-cigarette use. And the reason why this is, it is so very rare in this population. So it doesn't actually matter if there were a huge gateway, because hardly anybody uses e-cigarettes in that age group in the UK. Now, if we look at the older age group, you can see here the model data and the real data. There's a bit of divergence, but even at the end, you can see that the 95% confidence interval for the 2017 data falls within the line that we predicted. And so here's the impact if we assume there's an increase of an odds ratio of 3.5 times of e-cigarette use on subsequent smoking, and you start seeing that this becomes unrealistic as we go further out. So likely, again, suggesting these effects are probably not the case if you assume, in fact, an effect of 10 times the likelihood. And this is the data if you assume there's a beneficial effect, so a protective effect, and we can't really differentiate that either. So I think that suggests that for above 16-year-olds, model data are more consistent with no or positive effect in the UK. Because I don't have very much time left, I'm not going to go through the US data. The only difference for the US data, we did exactly the same thing, is that you can actually see an impact among those kids who are less than 16 years of age. This is because the prevalence of e-cigarette use is higher there, and so it's perhaps not surprising. And what it suggests here is for middle school students in the US, unlike in the UK, you can see an impact, and what it suggests is a negligible, if any, net effect. And as we've seen in the UK, if you look at those who are in high school, the results that we see here suggest that the effect where there's a gateway that is positive, i.e. that increases the likelihood of subsequent smoking, is unlikely, starts to become unlikely as soon as we go a couple of years out from 2014 onwards. This is for 3.5 times odds ratio, this is for 10 times odds ratio, and this is we assume there's a protective effect. There's halving in the likelihood of subsequent smoking if you have an e-cigarette first. So here for high school students, model data appear more consistent with no or positive net effect. Now I'm being told off, I'm going over time, but I just want to make a couple more points, if you allow me to. I'm going to try to speak as slowly as possible. And this is that there's a recent change in the use pattern in never smoking adolescents in the UK versus US. And we just mentioned this already. So this is the use of e-cigarettes among never smoking adolescents in the USA. And you can see in 2018 it went up quite a bit. It's now 16%. For the UK, the data suggests it's also gone up. It's around 5% currently. So this is e-cigarette ever use among never smoking adolescents. Now, what we're really interested in when it comes to the gateway, though, is presumably regular use of e-cigarettes among never smokers. And here is the weekly use of e-cigarettes among never smokers in the US and in the UK. And this is what you can see in the US, and this is what you can see in the UK. In the UK, in fact, it was estimated to be 0% in 2018. I think it's quite similar in 2019. But what you can see in the USA is that it has increased quite a bit. And actually now not 0.6% Konstantinos, it's actually 2.1%. So this is weekly use among never smokers. Weekly use, yeah. So relatively regular use. And the increase is much larger than what you see among, in terms of ever use. So I think obviously something is going on there, and one has to be wary of this and continue monitoring the data. And so why is there this difference that we observe in the US versus the UK? And I think there are a couple of reasons for this, and this is also relevant to the Greek context. The first one is that initially e-cigarettes had light touch regulation in both the US and the UK, but they became increasingly more tightly regulated in the UK and also in Greece because of the Tobacco Protocol Directive. And so, for instance, in 2013, I pointed out in 2013 there were no differences in e-cigarette use among adolescents in the UK versus US, and then it started to diverge. In 2013, they had early e-cigarette TV ads in the UK, which were summarily banned soon after, because people complained about them. Whereas there was an increase in the marketing spent in advertising in the US from 2014 to 2016, and also targeting of adolescents. And I think that probably has had an impact on the use of e-cigarettes among adolescents in the US, increasing not in the UK so much. Clearly, there are also different types of products available. So you have nicotine salts at 5% available in the US. In the UK, it's only 1.7% because of the Tobacco Protocol Directive, which may explain the recent increase in regular e-cigarette use in the US versus the UK, insofar as we assume greater nicotine delivery probably increases the addictive potential of a product. And lastly, or penultimately, I think the discourse in the UK is somewhat different to the US, insofar as in the UK it's mainly centered around adults and smoking cessation as treatment, given various reports, whereas in the US it's mainly centered around e-cigarettes as a consumer product. And lastly, which is interesting, I think, to point out, is that the use of e-cigarettes in adults is exactly the flip side of use of adolescents in the US versus UK. So in the UK, it's much more likely that adults are using e-cigarettes than adolescents, whereas the opposite is the case in the US. And I think it means that also they may therefore be much less appealing. Just to give you an idea why, in the UK, what you see as an adolescent, you see an advert for e-cigarettes as a way to help you stop smoking. From National Health Service or something like that, and you see your parents using e-cigarette across the breakfast table. Not very appealing or sexy. Whereas in the US, until recently, you would see adverts like this, very much targeted at adolescents. And I think that must have something to do with the difference in the use of e-cigarettes. So, coming to my conclusions, already 3 minutes over, I'm so sorry. I think if you look at the individual gateway, based on the case control design, evidence suggests a rather trivial truth, which is those kids who would likely have never smoked and they use an e-cigarette are probably at an increased risk of smoking after they have used an e-cigarette. So I agree with your assessment there. But I think adolescents who likely would have smoked, our data suggests, are probably at a decreased risk of smoking uptake following e-cigarette use. Because if you would have smoked anyway and you have an e-cigarette first, why would you then go on to use something that is quite unpleasant, essentially? So there's both a protective and a harmful effect there. If you look at the population gateway, so the net effect, at the moment the data suggests there's no evidence for a strong effect either in the US or in the UK, despite the fact that the use of e-cigarettes is quite different in both of these countries. However, I think there's continued need to monitor data and cross-validate results in light of the fact that the use pattern is changing in the US versus the UK at the moment. And the reason for this is if you work it out, if you think about it as a net effect, in a country where smoking prevalence among adolescents is very high, I think e-cigarettes probably are quite helpful in driving down smoking prevalence. But if in a country suddenly we get to the stage where more and more kids try e-cigarettes who would never have smoked, then it may very well flip, and then may actually increase smoking prevalence again. And I think in the Greek context, I would say that the TPD gets it about right. But I think member states, including Greece and the UK, could do better. Firstly, endorse e-cigarettes as an effective harm reduction tool for adults. So don't treat e-cigarettes like cigarettes. They're quite different. They are a harm reduction product. But obviously, try to restrict advertising and selling of e-cigarettes to adolescents as a cool lifestyle choice. Thanks.